Good afternoon, team. So if you can hear me, please comment in the comments. Good afternoon, Najaya. I'm assuming you can hear me. So today I wanted to talk about the nature of roots of quadratics. Okay, can you please comment if you can hear me? This is fantastic. So, a quadratic equation, as we've been experimenting with over the last few days, fantastic. Thank you so much, Urja. Thank you, Najaya. A quadratic equation over, as we've been experimenting with the last little while. Hi, guys. Very, very nice. They look in this form: x plus 7x plus 12 equals 0, and this part here gives us an indication as to what kind of thing we're looking for. But typically, they're equal to 0. Okay. And now, so far, most of these equations we can solve. And if we can't solve them, we've come into a very similar problem. Our calculator might, if you know how to do it on a calculator, our calculator might say, oh, you can't solve this. But often we don't really know why. So let's start with this one. Let's do the solving. So let's factorize this. This becomes x plus 3, x plus 4, and that's equal to 0 still. And so what are my solutions? Yes, x equals -3 or x equals -4. And that kind of makes sense. And okay, cool. What can I tell about an equation without having to solve it? I want to ask the question, can we determine how many solutions a quadratic equation will have without solving? Can we find out how many solutions there will be without actually solving? And that's the key question. Because sometimes solving, it's fun and all, but we want to know how many there are without solving. So I'm going to put up a few questions, 1, 2, and 3, and I want you to tell me how many solutions they have. Whether you solve them or not, I don't mind, but here we go. Question 1. X squared plus 6x plus 5 equals 0. How many solutions does that one have? Next question. X squared plus 6x plus 9. How many solutions does that one have? And then next question. X squared plus 6x plus 12 equals 0. How many solutions does that one have? I'm going to leave them there. I'm going to actually ask you to work them out maybe. And tell me in the comments. I will wait. I don't want to know what the solutions are. I want to know how many. Hi guys, it's nice to see so many of you on here. This is great. Thank you to that one person who's liked this already. Outstanding. Okay, here we go. Let's read some of these. Monique says there are 2 in the first, 1 in the second, and 3. Okay, Rosemary says 2, 1, and no solution. What does no solution mean? So we've got 2 solutions, 1 solution, and no solutions, maybe. I want to unpack that a little bit. And what I'm going to do is I want you to realize that quadratic equations are... Ooh, that's not what I meant to do. I don't know what they will look for you. Quadratic equations are the algebraic representations forgot to include a few letters in there. Representations of parabolas. Okay, and since they're algebraic representations of parabolas, we got to solve them as parabolas. We can look at them as parabolas. Okay, so I'm going to pull up some parabolas for you, and we're going to have a chat. Here's what I prepared earlier. Look, I've got 3 parabolas. Notice that I haven't put an x-axis or a y. I've put an x-axis, but I haven't put a y-axis because it doesn't matter where. I want us to look at how many times this equation, or this, so we'll call this question 1, we'll call this question 2, and we'll call this question 3 again. How many times does this red parabola go through this axis, this x-axis? And I can see 1, twice, 2 times, only once. And in fact, this is sitting above this line, and so it doesn't go through any time. So I will say 2 intercepts, 1 repeated intercept, and no x-intercepts. Okay, and now another way of saying x-intercepts is, in algebra, we call them roots. Okay, and I'm going to put one word in here. I'm going to call them real. Okay, 2 real roots. Okay, the word real is a type of maths number, and we will unpack this more next year. I might do another session on real and non-real numbers later, but for now we'll just include this word real. Okay, so 1, once again, include this word real, repeated root, and here no, I'm going to put the word real in here again, roots. Okay, once again, what's another way for saying x-intercepts or roots? We could say solutions, but I'm going to just leave it there. Okay, so the number of times it hits the x-axis. Here, the x-axis is 0. When y is 0. When y is 0. That's when the x-axis is. It doesn't matter horizontally, I don't care so much. Okay, and so this is really important. Based on your quadratic, in this form, oops, sorry, wrong color, ax squared plus bx plus c equals 0, can we determine a way of identifying how many roots or x-intercepts or solutions? And that's what we're going to look at today. And this should come as no surprise, but I'm going to come back to the quadratic formula, the one we did in the last video. Okay? Oh, 6 likes. This is great. I'm gonna get famous over here. All right. So I'm gonna bring up the quadratic formula. Does anyone have any questions? If you have any questions, just put them in the comments, please. Okay. Okay. Just gonna move my computer closer to me because it's finding it really hard to write today. So the quadratic formula. Once again, see if you can write this down without looking at the screen first. It would pay a lot to memorize this. It will be given to you, but it's good to know. Ooh. Okay. Thank you, Ronan. All right. So this is the quadratic formula. Let's look at this quadratic formula. Let's inspect this quadratic formula and see where the weird stuff happens. Okay. So I'm going from a squared plus bx plus c. Does anything weird happen if I take a number and take it over? I take b and I take negative b. Anything weird happen? Nah, not really. Does anything weird happen if I divide by 2 times this number? Not really. What about this part here? This part here. Oop, that's not what I wanted. This part here is a plus or minus. And all that means is I can write negative b minus b squared minus 4ac over 2a. Or I could write negative b plus b squared minus 4ac. The square root of b squared minus 4ac. So that's all this plus or minus means. It doesn't really tell us anything too scary. Okay, but the key thing here is that there is a square root. And this square root is where things get crazy. Because I want to ask you a question. Let's go back to what we had before. Let's look at this square root. For question 1, question 2, and question 3 from above. So if you don't remember, I'll just write them out again. X squared plus 6x plus 5 equals 0. X squared plus 6x plus 9 equals 0. And x squared plus 6x plus 12 equals 0. Can you... Oh, hello. What just happened there? I'm not sure. If you lost that, could you hear me? I'm not sure. All right, so for these ones, I want you to find out what is underneath the square root. This b squared minus 4ac. Work out what each of those is. And I'm going to give it a special symbol. I'm going to call this symbol, I'm going to give it a certain symbol, and I'm going to say it's the thing that changes things. So I'm going to draw a little triangle there. Okay? And this triangle is the Greek letter capital delta, okay? But it stands for change, right? It's what changes in the equation, what causes the changes, right? So you'll see delta quite often. In physics, you'll see delta quite a lot. In maths, you only see it a few times, right? And one of the few times is in quadratics. And this delta has a special name. It is called the discriminant. Okay, I want you to try and unpack the word discriminant and see if you can figure out what it means. Sorry, my computer's doing all sorts of weird things sometimes. Right, the discriminant. Right, see if you can type in what you think the word discriminant means. Okay, whilst you do that, I'm going to come back and try work out what the delta of each of these is, or the discriminant of each of these. Okay, so the discriminant of the first one is b squared, so 6 squared, minus 4 times a, which is 1, times 5. Oh, oh my god. I'm going to actually turn off this situation because I think it just likes my brackets really well. Okay, here we go. Okay, so 6 squared is 36, and negative 4 times 1, so that's negative 4, times 5, so that's minus 20. So this is equal to 16. And this one, triangle, or the discriminant, is 6 squared minus 4 times 1 times 9. 36 minus 4, negative 4 times 1 is negative 4 times 9 is 36. Okay, and then this last one, 6 squared minus 4 times 1 times 12. 36 times 4 times 1 is 4 times 12, 48. Okay. So, I've worked out the discriminant for each of these. Okay, whilst you guys just check that, the word discriminant, the only person who's responded to me is Ronan, so thanks, Ronan. But the word discriminant means what discriminates. So if you're trying to, what is the discriminant between a group of students? It could be the age. I might put them in different classes depending on how old they are, and their age becomes what I discriminate based. Okay, it's kind of, from where the word discrimination comes from. We discriminate based on certain characteristics, but it's not the negative connotations of that, but rather the factual connotations of that. What is it that we're using as the judgment or the thing that we're measuring to compare with? So if I had a whole bunch of students at our school and I look at a student and I want to know what year they are, well, their uniform is the discriminant. If they're wearing white shirts, they're year 11s or 12s. If they're wearing the green shirts, they're year 9s or 10s. And if they are in mufti, they're year 13s. And that becomes the discriminant for deciding between what years they might be. Right? It doesn't tell us everything, but that's how it works. And so in our situation, this discriminant tells us how many solutions there are. Okay, so let me write up a little bit about the discriminant. All right, so okay, So if ax squared plus bx plus c equals 0, we can use the discriminant to determine how many solutions a quadratic has. Okay. How do we do that? Well, if you notice up here, we said that this one had two solutions, or two real roots, one real root, and no real roots. And let's see if we can use that information to form a statement. Here we go. If the discriminant greater than 0, if discriminant is positive, okay, then we have two real roots, or two solutions, okay? Oh, I'm going to just move this down a little bit. If the discriminant is equal to 0, if discriminant, I'll just erase that. Then one real repeated. I like using the word repeated because it indicates to me that it's the bottom or the vertex of a parabola. Okay, one real repeated root, and then the last case, if the discriminant is less than 0, if discriminant is negative, remember anything less than 0 is negative, right? Then there are or 0 real roots. Or I'm going to no real roots. Okay, some of you might want the word roots, or 0 instead. Okay, so we've got this discriminant, and if it's positive, then there's two real roots. If it's 0, then there's one real repeated root, and if it's negative, there are no real roots. Okay, let me just write the discriminant here again. Remember, the discriminant is equal to b squared minus 4ac. And why is it this? It's because in this quadratic formula, it's the thing underneath the square root. And you cannot take, well, this year, you cannot take the square root of a negative number. Okay, so if the inside is positive, we good. If the inside is 0, the square root of 0 is only 0, so you're only plussing or minusing 0, so it doesn't change. And then if this is negative, if the inside is negative, then you can't square root it yet. And because of that, we say there are no real roots, because you cannot do anything with it for now. Okay, and that's really the biggest part. So if I now give you a whole stack of quadratics, using this pack of information, you should be able to tell me whether there are A, two solutions, B, one solution, or C, no real solutions. Okay? And that is something now you can do for any quadratic. I can just make up a whole stack and you'll be able to tell me. Okay? So, as an exercise, here you go. How many roots are there? Okay. Question 1. 3x squared plus 4x plus 7 equals 0. Question 2. 2x squared minus 11x plus 1 equals 0. 3, 8x squared minus 1x plus. Oh, I'm going to change this to minus 12. No, I'm not actually. Oh, I'll be nice. Minus 2. Okay, those 3 questions. Have a go. I'm going to leave that there, and then I'm going to put another 3 questions over here. Okay, give these a go for me, okay? First 3 are a little challenging, next 3 are a little easy. I'm trying to get the point across. Make sure you check your minus signs. And once you're done, type your answer in the comments, in the chat rather, and we'll see. And yeah, I'll be quiet so that you guys can work for a little bit. And if you're watching this later, maybe just pause here so that I'm not talking. Okay, I can see Leon's put some answers through, but others of you, you can type in your answers too. Yuji, you agree with Leon? Cool. Well, Leon's got 3, 0. Urge's got 3 is 2. Okay, so let's have a look at that. Check it again. Okay, so what I'm going to do is I'm going to just write the discriminant for each of these, and I want you to tell me what you think it is, okay? So here goes. The discriminant for this is b squared, so 4 squared, which is 4 squared minus 4 times 3 times 7. I'm going to whack that in a calculator, and I get, what do I get? I get 4 squared minus 4 times 3 times 7, and that is negative 68. Okay, and then the next one, I get 2 squared minus, no, I get negative 11 squared, which will still give me a positive number, minus 4 times 2 times 1, which is 113. Okay, and then this one here, I get negative 1 squared minus 4 times 8 times negative 2. And that to me is 65. And so for these three, this is negative. And since this is negative, no real roots. Positive, so 2 real roots. Positive, so 2 real roots. Okay, and let's come over to here and let's see if we can do these. The discriminant is 7 squared minus 4 times 1 times 6. And so that's 49 minus 24 is 25. So once again, 2 real roots. You could probably write the whole thing out. Sorry, I don't want to move the whiteboard much. Okay. This one here is 7 squared minus 4 times 1 times negative 6. So once again, this is 49 minus, or plus 24 in fact, 73. So once again, 2 real roots. And then the last one, okay, and I see a lot of you get very similar answers. This is outstanding. And then the last one is delta, or discriminant is negative 7 squared minus 4 times 1 times 15. And so this is 49 minus 60, and that's equal to negative 11. And so this is no real roots. Okay? Okay. You guys should use this shortcut. It's just I don't have whiteboard space. You should write the whole words out, okay? And if I were to give you one that gave you a nice one, does this make sense to you? Are we all okay with the fact that if we can use the discriminant, we don't need to know what the solutions are. You can find them out using this discriminant. So you know what the square root's going to do, and you don't have to plug it in. Okay. You don't have to try and find the solutions. Sometimes you just need to find out the nature of the roots, okay? Yeah, I'm seeing a lot of you with the same kind of answers. Well done, guys. I'm really liking this. So the question is a little harder. If I gave you an equation, I'm going to actually not call it this. I'm going to do an easy one to start with. And do x squared 8x equal plus q equals 0. Now here's my question. What values of q give you real roots? And this will be I II will be 1 real root. III is no real root. Okay. Let's see if you can work those out. Do we have these questions in the workbook? Yes, we do, Enoch. Yep. Sorry, I was going to get to that. These questions, this kind of question is on. Give me 1 second. If someone else knows, feel free to answer. But I have a feeling it's page. Give me 1 second. Someone else, if you know the answer, go ahead. Yep, so this stuff is on page 61 and 62. And the stuff I've just asked you is on page 64 and 65. 64, 65, 66. 61, 62. Page 61. Oh, no, sorry. 60. Oh, we'll just change it. 61 through 62. And then this stuff is page 64, 65, 66. Okay, there we go. So let's work out the values of Q. What values of Q will give you 2 real roots? What values of Q will give you 1 real root? And what values of Q will give you no real roots? Okay, I'm going to almost stop this video very shortly. Okay, so quick question: did I start the stream late? Now this has always been at 4:30, right? I think. Anyway, yeah, cool. Just had like a minor panic moment where I wondered whether I started the stream late. Okay, so I'm going to do this question. Let's work out what the discriminant of this is. Remember, I'll work out that A is 1, B is 8, and C is Q in this question. So the discriminant is 8 squared times 1 times Q. And so I have 8 squared is 64 Q. This is what the discriminant is. So question 1. When I'm going to actually do, I'm going to do question, 1. Let's go. When is this, the discriminant, greater than 0? Because that's when the discriminant is greater than 0. Okay. So what I'm going to do is I'm going to try and solve this.
Just message through any supermarket stuff.
Okay, cool. That was my flatmate, guys. All good. So I'm going to now solve this, and so I am going to move 64 over. By subtracting it, and then I'm going to divide by -4. And remember, when I divide by a negative, I swap the sign. And so Q is less than 16. If Q is less than 16, then I will get real roots. And can you notice that it's an inequality? Do we have live tomorrow? I don't know yet. I might, but I need to really gauge interest in how much you guys want to. So if you do, just type in here, yes, please, let's do a live tomorrow. And if you could list a topic that you want me to do, and we might, okay? But currently, I'm not going to. Okay. Question 2, 1 real root. Okay. When is this, the discriminant, equal to 0? Once again, I'm going to subtract 64. You might notice a pattern here. I'm going to divide by -4. And when I divide by -4, I don't need to swap the sign because it's an equals. And so x equals 16. Okay, q equals 16. If q was 16, then I would get one real root, or one real repeated root. Okay, and then the last one, I'm going to try scoot this over just a little bit, team. Sorry, I should have planned a bit better. Okay, here goes. This is going to once again be 64 minus 4q. And this time it's going to be less than 0, because that's what is negative. Okay, and then I subtract 64 from both sides, and then I divide by -4. Once again, if I divide by -4, I flip the sign, and so q is greater than 16. And do you notice that that 16 becomes a very important value? So on one side of the 16, on one side of the 16, it's no real solutions. No real roots. The other side is 2 real roots. And at 16 is 1 real root. And that's kind of cool. All right. You've got to say, okay, guys, a lot of you said yes, please, but on what? That'd be helpful. All right. So maybe I'll put up a survey later today, and if you can ask questions on that survey, then we'll continue. So now what I've got is, let's just quickly go back to here. I'm going to zoom out a little bit. Will that let me do it? I'm not sure. All right. So my question is, what values of q give me 2 real roots? Well, anything less than 16. What value of q gives me exactly 1 real root? Exactly 16. And what value of q gives me no real roots? Any value of q that's greater than 16. Now, these questions on page 64 to 66, there's a few variants on that. So I put q here, but you could change this and this one, and see how the maths changes. But all in all, it's not that different, and you've got to just make sure that it all fits together and works. I am going to call this here, so if you have a question, just ask me now. Otherwise, I will stop the stream soon. I will just wait, and then I might stop the stream. So I hope you enjoyed that. It's been really fun doing 4 streams. If you'd like more streams, please let me know, and talk to your teachers about what you need. The likelihood of us having online learning for a little longer is guaranteed. We will probably have online learning for at least the next 3 weeks, and then we'll see what the government decides to do after that. But I can guarantee that we will have online learning for the next 3 weeks at least. So be prepared to continue learning this way, guys. Be engaged and be doing work. Okay, team. None of you have asked questions, so I am going to end the stream here, and I'll catch you in the next few days. Thank you.